Hello everyone, today in this video we'll be discussing the third module of Theory of Computation, which is related to two topics, CFG, which is context-free grammar, and Parse Trees. I mean the PDF, Pushdown Automata. Okay, so we'll be discussing, there are four topics here, and the second and third topic are very small. The main topics are the CFG and PDA. We'll be discussing the questions which can come in exam. And before starting, make sure hit the like button, subscribe to my channel for more videos like this. And if you watch this video till the end, easily you can score more than 80% marks. Without wasting any more time, let's get started. So the first topic is the CFG, context-free grammar. So let's get started directly from the questions. You can understand what we have to do. Okay, so the question can be as follows: obtain a CFG to generate any number of A's. Okay, so we have to generate any number of A's. For that we have to generate a CFG. Okay, and the alphabets given is only A. Okay, so any number of A's means it can include A followed n number of times. Okay, so here what we do is we will denote a letter S here. Okay, S is known as the starting state. S goes to AS, and S can go to epsilon, means S can be empty. See, any number of A's means A can be empty also, right? So S can go to epsilon, means the string will be empty, and that is also valid string. If I want a single A, what I will do, S goes to AS, I will write. Okay, S goes to AS, so I have AS here, and instead of this S, I'll substitute it as epsilon. So what will happen, I'll have AS here, and this will get epsilon, so only A I'll have. Suppose I want to generate two A's using this, what I will do, I'll do S goes to AS, and again this S goes to AS, right? So it will be AAS, and this one I will substitute as epsilon, so here it will be AA. Like that I can keep on generating in a loop n number of times how many A's I want, and then when I want to end, I'll end it with epsilon. Okay, so that is how you obtain a CFG. Okay, let's discuss another question. Generate a string consisting of at least one A. So the minimum string will be A here. Okay, so here after that, after one single A, I can have a number of A's, right? So I'll define it as follows: S goes to AS. Okay, for generating n number of A's here, and S can be substituted as A. I cannot do it as epsilon. If I put here as epsilon, what will happen is, you can think it as follows. If I put here epsilon, what it could be possible in this way, right? S goes to AS, and this S is substituted as epsilon, and single A is still there. But if I write S goes to epsilon, I can directly take this one. So when I take directly this one, epsilon string will be accepted. But that should not be the case. At least one A should be there, right? So if I want one A, I can go with this one. If I want two or more A's, I can go with this one and finally substitute this one. For example, if I want double A, okay, first I'll write S goes to AS, and then this S I'll substitute it as A from the second rule. So it will be AA here, right? AA will be there. So this is how you generate string for at least one A. Okay. Moving on, we have the generate string consisting of any number of A's and B's. So here two letters are there, A's and B's. So for this, I'll do S goes to AS, S goes to BS. So S can be either substituted as AS or BS or epsilon, right? Because any number of A's and B's can also be zero, right? So this is the CFG for any number of A's and B's. Generate string consisting of at least two A's. Two A's should be there at least. So minimum string will be 2A, as goes to 2A here, and followed by n number of A's. To generate string consisting of even number of A's. Here the number of A's should be even. So what can be the minimum string? 0 A's, 2 A's, 4 A's, and so on. So here I'll write it as double AS. So again, if I substitute S as AAS, it will be again AAS, 4 A's will be there. Again, if I substitute as AAS, it will be 6 A's. If I just directly take it as epsilon, that is also fine, because 0 is even, right? So this is how you generate string for consisting even number of A's. Next, generate strings of A's and B's whose string length is multiple of 3. Okay, multiple of 3 means whatever I have generated a string A, B, B, A, like that, this whole length should be a multiple of 3. Either it should be 0, or it should be 3, or it should be 6, or it should be 9, and so on. So the least one is 0, so I'll take S goes to epsilon, which can be 0. And for 3, what I need to do, I'll write it as A, and A can be either A or B, right? A small a or a small b can be substituted in the place of A. And after filling this one, you can again go with another 3A, or you can stop it using epsilon. Okay, so this will ensure that it is always a multiple of 3, right? Moving on, generate any number of A's and B's with at least one A. Okay, here A's and B's both is there. The previous one which we discussed was only A's, right? A's with at least one A. Here we have B's also. We need to handle B also. So whenever you have this type of question and you're not able to understand how to start with this one, first make the DFA of it. Okay, how do you make the DFA? S is the starting set, so make S here and make a DFA for this following question: A's and B's with at least one A. So here it will be B here, self loop will be there on S, and whenever an A will be there, it will reach the final state, and in the final state it is A which will be having n number of A's and B's accepted, because at least one A is the condition. So do the same thing here. S goes to BS, right? S goes to BS. So right here S goes to BS. After that, if A is there, where it is going? It is going to capital A. So S goes to A and capital A. Then capital A is going where? Through A and B it is going again to A. So through A it is going to A, through B it is going to A, and as well as you can stop at that point without taking any more A's and B's. So epsilon is also valid. Okay, the condition is at least one A. If I take capital A as epsilon, that will be satisfied here. Direct one A. Okay, so that was about A's and B's with at least one A. Moving on, we have this type of question where we have a substring. Okay, A's and B's, you have to generate a string with a substring AB. Substring AB means in between you should have AB, or it can be at the start also, it can be at the end also. So A or B can be there or it cannot be there. Both choices are there. A or B can be there or cannot be there. Anywhere it should have AB. So the least string is AB, right? So see here. Uh, Followed by AB, you can have A in the beginning and capital A at the end, and AB should be there for sure. So this A can either be epsilon or it can be n number of A's or n number of B's in any order, right? That can be there in the starting or the end. In between, AB should be there definitely. So AB we have directly written here. That was about the strings having A's and B's substring AB. Moving on, this type of question can be asked where L will be given W such that number of A's in W mod 2 is equal to 0. Okay, and the letters are A and B. So how many A's are there in the string? That one should be even. That only means mod 2 is equal to 0. Even number should be there, either 0, 2, 4, the number of A's. Okay, so least string is 0, so S goes to 0. And since B is also there here, I can have n number of B's in the starting. That will still ensure that A is still 0. So after I have done this one, I have to have a multiple of 2, right? 2 A's can be there, and before A and after A there can be S. S can be either B's, n number of B's, or it can be epsilon, or S can either be this one also. Like if I substitute this S as SAS, then it will be again continuation with this one, ASAS, like that. Okay, that is also possible, but always it will ensure that 2 A's have come and any number of B's can come in between. Okay. Moving on, L is equal to A power n, B power n is greater than or equal to 0. So here, whenever I have an A, I have an equivalent B present here. So I can write the CFG as S goes to A S B. So this S can be substituted again as A S B. So what happened? Double A came here, double B came here. Again, this S I can put as A S B. What happened? Another A came, another B came. So this ensures that equal number of A's and B's are coming, and whenever I want to stop, I can stop it with epsilon. Okay. So since here n is greater than or equal to 0, it was written equal to 0, so we can directly take epsilon also. Okay. So similar question here, but it is a bit different. Here we have A power n and B power m, means the number of A's and number of B's are not equal. N can be greater than or equal to 0, and m should be always greater than n. Okay. So what is the least value of n and m possible? Least value of n is 0. So when n is 0, m is greater than n, means m should be 1 or more. 1 or more, if I do m and n is 0, n is 0 means this power 0 will cancel it, and b power m is equal to 1 means it will be b, 1 or more, right? So it can be b or b. How many b's I want? After a single b compulsory, I can have n number of b's, so it will be b star. This can be either 0 or more, right? And if n is equal to 1, what is the case? If n is equal to 1, here it will be a, and here it will be m2. M2 means b, and after that I can have b star, right? So see here, a b, then b star. AB I have taken together and B star I have taken here. Okay. So see, one thing you can observe. This is the minimum string. Minimum string always comes at the end here. So that can be denoted by a letter. Okay. Here I'll denote it as capital B. So capital B denotes B star. And A denotes this one, AB. Okay. Okay, so this is divided into two parts, AB and BB star. And AB, it is looking like this, A and B is there, but actually what it is, if suppose that I take n is equal to 2, okay, now you will understand a pattern here. Okay, so suppose that I took n is equal to 2. If n is equal to 2, it will be A here, m will be equal to 3 or more. Okay, so what will be the string? The string will be A will be here, and m is 3. M is 3 means B then B star, right? 3 or more. So 3 B's are here or more. What you can observe is this is following the pattern A power n, B power n. So this thing I can take as A, which denotes A power n and B power n, and this part denotes the minimum string, which is B star. Okay. So how do we denote it using the CFG? Okay. So CFG, I'll take two letters A and B. A will denote A power n, B power n. That is equal to nothing but A and B. A can be substituted again as AB, so it will be A power n, B power n, and epsilon can be here. And this is B star. So either it can be B can be either B or n number of B's. So it will be B and followed by the capital letter B. So this B can be substituted again as BB, and this B again can be substituted as BB. So it will be forming a chain of B's followed by a B, and this B can be finally substituted as small b. So if I want two B's, what I will take? First I will take BB and I'll substitute this as B, so it will be BB. If I want one B, I'll directly take this one. Okay, so this is how you represent the two parts here, A and B. Okay, moving on to generate a language of all palindromes over the letters A and B. What is a palindrome? Palindrome means the starting part and the ending part from here should be same. That is a palindrome. Okay, so palindrome can be, if I take here as A B A B A. If you take read from here and if you read from here, it will be same, right? A B A A B A, right? So that is called as a palindrome. Okay, so if you read it from the start to end, from the left to right and from the right to left, both will be same. Okay, so to generate that one, we have to make a language such that whenever an A comes in the left, correspondingly A should come in the right. Same goes for B here, because palindrome will form whenever the starting and the ending letter are same at the same time it's written, right? Then only a palindrome can form. So in between, what can be there? It can be either epsilon, or it can be A, or it can be B, right? So epsilon A and B. This is for even palindrome. If I put epsilon, it will be even palindrome. If I put an A and B in the middle, that will be an odd palindrome. But nevertheless, it is still a palindrome. Okay. So this was about the CFG. And moving on to the next topic, which is the parse trees. Okay. So parse trees, you have to remember concept here. The grammar E goes to E plus E. So if E is present here, I can write that E as E plus E. Okay, this will understand when we solve a problem. E can be written as E minus E, E into E divided by E, E power E, and E goes to ID. E can be substituted as ID. Okay, so the question can be as follows. Okay, this is a previous question, very important one. W is equal to ID plus ID star ID. Now we need to obtain leftmost derivation, which is LMD, and the rightmost derivation, which is RMD. Okay, so what do you mean by LMD and RMD? So in LMD, we'll be starting from the left. Okay, from left we will be starting. Okay, so when you start from the left, what is the first operator you encounter? It is plus, right? So E can be written as E plus E. Following the rules, I want plus first, so I'll be writing E is equal to E plus E. Okay, so here E is equal to E plus E, and E can be substituted as E plus E. Okay, and E can be written as ID. Okay, because I have to start from the left, and first letter is ID, so I'll be substituting it as ID is equal to ID. This one I'll be writing first, and here it is plus E. Okay, now after I have solved this one, I have to solve this one. Okay, so I've solved for ID. Next, what it is there? Plus is also there. Now next, what it is there? ID star ID. So I have to generate this one. To generate this one from E, I'll be substituting E as E star E, so that star will come in between. Okay, star has to come in between. So if I directly take it as ID, then it will be over. I cannot expand it. So I need to first expand it so that I can later on substitute it one by one and form this one. Okay. Then if I do it from the left, it is called as LMD. From the left, I'm doing first. I'm taking it as plus, then I'm taking as multiply. Now if I take it as from the right, that is called rightmost derivation. Okay, so in the rightmost derivation, here it is a star. Okay, so star I will take it as first. Okay, so here I have written it like this, but it is not like that. Let me make the change. Okay, it is not like that. First, RMD means I have to take it from the right. Right, I have to take it from the right. So I'll take it from the right only. Okay, see here, E star E. Okay, let me clear off this. I'll do it one by one. See here, E star E is there. Okay, now from the right I have to take. E can be substituted as ID, right? So here I'll write as E star ID. Now after star is done, ID is done, here I should have E plus E. Okay, so this I'll substitute as E plus E star ID. Okay, then I'll substitute this as ID, E plus ID star ID, and then this E will be substituted as ID plus ID star ID. Okay, so this is how you do the leftmost and the rightmost section. Okay, moving on, the main thing we had to make is the parse tree. Okay, so parse tree, how we will make? See, parse tree you can make for the leftmost derivation or for the rightmost derivation. For the both of them it's possible. So let's have a look at the leftmost derivation. How do you make the parse tree? Now see, what did you take first? E is equal to E plus E. So here you write E is equal to E plus E. This E you substituted as ID, so here you will be writing it as ID. And this E you substituted as E star E, so here it will be E star E. And each of these E substituted as ID, so you'll be writing here as ID. Okay, so the obtained equation will be starting from left because it's the leftmost derivation. ID plus ID star ID, it will be like this in the bracket. Okay, because this is a subtree here. Okay, here main trees are E plus, then E is further divided, right? So this will be in a bracket. So it will be ID plus ID star ID. Okay, so this is called as a parse tree. Okay, by using the equation of this derivation, you will be generating a tree that is called as a parse tree. Okay. Moving on, we have the ambiguous grammar. Okay, what do you mean by ambiguous grammar? We'll understand. Okay, consider the grammar and check if it is ambiguous. The same question is given here. W is equal to ID plus ID star ID. Okay, rules are given here. First write the rules. One thing is different here. E is equal to E or I goes to ID. You can't directly take ID here. You have to first take E, then first you have to take I goes to ID, like that. Okay, now see, you have to derive both LMD and RMD. Okay, both you have to derive if you want to check if it's ambiguous. So for the leftmost tree, E plus E, I plus E, ID, like that you will be substituting from the left. Okay, and you'll obtain my equation. Based on these derivations, you'll be writing this one. E plus E, E plus E. Then second step, E became I became ID. This E became E star E. This E became E star E. Each of these E became I and ID consecutively. Okay, so you'll start from here. When you start from here, it is ID plus, it is in a bracket, ID star ID. Okay, this is LMD. RMD will be starting from the right. E star E will start from the right. First substitute this as ID, expand this one as plus, and then substitute it as IDs. So when you do it, take it from the right. When you take it from the right, this ID multiplied by a sub branch here, which is having E plus E. So E plus E or ID plus ID star ID. So this is the rightmost derivation. As you can see, the rightmost derivation and the leftmost derivation are not same. Therefore, the trees are ambiguous. Okay, this is how you prove the trees are ambiguous or not. And as well as parse tree, you will make it in this way. So both the things are covered here. Okay, these two are interrelated topics. Let's see another example here. See, one more thing. If you want to prove it as ambiguous, you have to try your best. Okay. See, I can make it in a way in which it will not be possible that both are not equal. I can make it equal also. I can follow such rules. I'll first take it as plus and follow other rules. But in that case, I'll be obtaining it as equal. But if there exists any way in which I can make it as not equal, then it is ambiguous. So I have to find out that particular way. Okay, that is the main concept here. From this question you understand. Okay, see here, it is given as s goes to as or x. Okay, and x goes to ax or a. Okay, and w which is given is a, like the w which was given to as id plus id star id, right? The w which was given here is id plus id star id. So whatever w they have given, for that w we have to find out the parse trees and check if it is ambiguous or not. Okay, so let's have a look at it. Okay, so the rules are this one. First LMD you have to calculate, then you have to calculate the RMD. So LMD will be starting from the left. So left I need first A. Okay, first what I need? A I need. So if I need A at the first, I have to take it as AS. I start from AS, I'll take as AS. Now, the further A's I can get it via X, right? So I can take X here and then AX. Another, this X will be substituted again AX, and the final X will be substituted as A. So here it will be A. So this is the LMD here. Okay. RMD will be, how will be the RMD? RMD will be as follows. S goes to X. RMD has to start from the left. Okay. So if I want to start from the left, first I need to have a singular A. To get a singular A, I have to first get the A from the left. But if I take AS, it is from the right. I can't take that one, so I have to take X. When I take it as X, I'll write as X here. AX I'll write, X will be substituted as AX, this X will be substituted as AX, this X will be substituted as AX, and finally this X will be substituted as A. I could have taken AS also. That is also not against the rules, but in that case I'll get LMD equal to RMD. Right? I need to find out a way in which I can get LMD not equal to RMD so that I can prove it. It is not. It is ambiguous. Okay. So if LMD not equal to RMD, that is called as ambiguous. So I have to find out such a way. Even though ways exist in which LMD will be equal to RMD. Okay, there are many such ways exist. But even if one way exists in which LMD will not be equal to RMD, then it will be ambiguous. So I have to find out that particular way. So that's why only I took X as first. Okay. So you can take AS also, but in that case you have to. It's your responsibility to arrive at an equation where LMD will not be equal to RMD. The easier way is first take X and then directly make the equation not equal. Okay, that is more simpler. If you found the parse trees, take AS and then substitute S as X and so on, you'll get the LMD here, and RMD will be in this way. X will be first and then the following tree. So as you can see, it is starting from S, it is same. Here we have AS, here we have X. That is not same. Therefore LMD not equal to RMD. The given grammar is ambiguous, you'll write, and this is for you. Try your best to prove it is ambiguous, even if one way exists and in which LMD not equal to RMD, the grammar is ambiguous. It's your task to find out that one way. Okay. If you fail to do that and you mark the grammar as not ambiguous, even if the way exists but you couldn't find out, then you will lose the marks. Okay. So make sure you practice these type of questions very well. And that was about the ambiguous and the parse trees. Moving on, we have the pushdown automata, the second most important concept, and this is the last topic from this module. Let's have a look what it contains. Okay, here we'll be having a finite automata as well as a stack. Okay, and it looks both at the input and the top of the stack. Okay, initially we'll have z0 in the stack. Okay, there are two types: deterministic PDI and non-deterministic PDI. One state transition will be there in deterministic. You only have the deterministic for your syllabus. Non-deterministic is not there. Okay, so all the questions which are solved here will be deterministic only. Okay, so let's get started. The question is PDF for so this is the language given to us. It is a power n and b power n, and n can be greater than or equal to 1. So what is the least string? AB followed by AAB, AABB, AAA, BBB. How many A's you take, that many B's you have to take here, and it is greater than or equal to 1. So least string will be AB here. Okay. So how this concept works in pushdown automata? So here we have a stack present. Okay. And stack's initial letter will be Z0. So this is the top of the stack, which will be Z0 initially, and whenever we get an input of A's or B's, we'll be pushing it to the stack. Also we'll be popping. So how do we do that push and pop operation? Okay, so let me demonstrate it. So here what we do, so see here, this is a stack. Okay, now suppose my string is AABB. Okay, Z0 is here, I pushed A, another A I pushed, but when I get B, I'll mark this corresponding and pop. Okay, another B I get, I'll mark the corresponding A and pop. And once I reach Z0 and there is no more input, that means the it's over. Okay, like that. So this is the concept behind it. So how many A's are there, that much will be pushed. Corresponding n number of B's will be pushed, I mean popped. Okay, and then epsilon will be there at the end. So if you reach a point, okay, listen carefully, if you reach a point after A's and B's, when the input is null, means the A's and B's are over, the input is null, and your top of the stack is Z0, that means the pushdown automata is correct. Got my point? Okay. So that's how we get to know if the pushdown automata is correct or not. So if I have another B here, what will happen? I'll have another B here, but I don't have a corresponding A for which this B will be popped, right? In that case, what will happen? I'll reach the end and I'll have one B remaining here, and there is nothing to pop, and the top of the stack is B and it is not Z0. That means the language is not accepted. Okay. So this is the concept. First, you have to make the DFA here. Okay. So how do you make the DFA? Very simple. Listen carefully one by one. Okay. Step by step, we'll discuss. First, make a state Q0. We are not sure how many states are there. First, make Q0. Okay. Now, in Q0, first I will be getting A's here, right? Because n is greater than or equal to 1. So I'll be getting an A here. So I'll make a self loop. I have to remain here because I have to accept n number of A's, right? So don't worry if it's getting confusing why I took self loop and not another state. It will get clear as we solve the questions. So stay patient and focus on what I'm saying. Okay. So what is the input? The first input, let's take this only, A, B, B. Okay. So A is the first input. Okay, let's take A, B, B, B for more better understanding. Okay, A I have taken. This is the input which I will take. And what is the top of the stack? The top of the stack initially is Z0. So top of the stack I will denote here. After this one, what is the status of the stack? The state of the stack is A come here. Okay, means I'll make this one. This is for this particular question. Z0 is here and A I have pushed here. Okay, so it is A Z0. The top two elements I have to write A Z0. Okay, that much only. Now, if the input is A and the top of the stack is Z0, then it will become A Z0. If the top of the stack was Z0, I put an A here, then only this will be considered A Z0. What if another A I put? If another A I put here, the top of the stack was A only. It was not Z0. So I cannot take this one. This was only in the case in the first where top of the stack was Z0. In this case, top of the stack was A. So I have to take another condition here. A is the input and the top of the stack was A. In that case, the top two elements will be AA. Okay, cool. Now AA I have inserted, another A I will insert here, insert another A here, again it will be AA. So this will be accepted. Now AAA is over, now next is B. When B comes, what should happen? When B comes, this should go off and the top of the stack should be A here and B should be popped. Okay, so we'll make another state. Whenever the popping will come, I have to make another state. We can't stay in the same state. Okay, popping whenever I'm going to pop. So now see, the input is B, right? So I'll be writing here it as B. B is the input and the top of the stack is A. If B is the input and the top of the stack is A, I have to pop it. Pop is denoted by epsilon. In popping will not denote what is the letters here. Okay, because that will get a confusion. If I put letters here also, how will I differentiate if I am pushing it or popping it? So popping will not denote anything, just epsilon will put. Very simple. Make another state here Q1. Okay, cool. Now Q1 is present here. Okay, now a question might have come why I did not take it here only. Let's suppose I took here only. Okay, what will happen? B, A and epsilon. Okay, B, A and epsilon. Then another A, if it is coming, A should be pushed. So in that case, what will get accepted? A, 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 B, A will get accepted. Because A, same state. B also, if I take in the same state, what will happen? It will remain in the same state. Next, another A comes, it will accept A also. So in this case, this will be accepted. But this should not be accepted. Why? Because A and B n. A followed by n number of B's. After B, A can't come. So I have to take another state to handle this situation. Got my point? Okay. So we'll create a new state Q1. Now I have created a new state Q1 here after the popping. Okay. Now only B's are there. Okay, I have to handle only B's. If A comes, that is not a valid one. I'll not handle A. I have to handle only B here. Now, if another B comes here, this B has come, another B has come and the top of the stack is A, that should also get popped. So here there will be a self loop where the input is B and the top of the stack is A, therefore I pop it. Okay. So here it will happen until I reach the end and the top of the stack is Z0 and the input is epsilon. See, number of A's and B's, they are equal, that only the case I have to accept. Okay, if they are not equal, if the A's are over and another B is there, that I'm not concerned about it. I am concerned only about the case when A's and B's are equal and epsilon has come, then I will handle epsilon here. Then the input is epsilon here, the top of the stack is Z0. I'll not do anything, I'll keep it as Z0 only. I'll not push, I'll not pop, I'll keep it as Z0, and I'll reach a state Q2, which is the final state. Okay, so we need not handle the cases which can be like dead states we used to do in the DFA, right? Another A can come here, I can go to the dead state, but I'll not handle that here, because if I don't handle it, automatically it will not proceed from that point and it will not reach the final state. That is common sense, right? So that's why we need not handle the dead cases in the PDA. Okay, we just have to handle what is accepted here. Okay, now this is the transition diagram. Next step you have to write is a transition function. That also, by referring to this one only, you'll write. I'll write for the first two or three. After that you write. Okay, in the exam you need to write for all of them how many states and transitions you have got. That one you have to make. Okay, now let's discuss how do you write the transition function. So transition function, first is q naught here. So write the transition function symbol here. Q naught is present. You got an input A here, and the top of the stack was Z naught. So you reach which state? You reach again Q naught only. And what is the top two elements? A Z naught. Okay, got my point. This is how you do it for it. And let's make for the next one also. Q naught is the state, and the input was A. Top of the stack was A. So I reach a state which is Q naught. Top two elements are A. If it is this one going to other state and pop, this was for the push. Okay, let's discuss the pop also. So pop will be like this. It will be q naught initial state and the input is B and the top of the stack is A, and I'll reach a state q1 where the epsilon is here because I have popped it, right? So I'll write it as epsilon and so on. This is for the pop. Whenever push comes, you have to follow the top one, and for the pop you have to follow the this one. Okay, like that you'll write for all of them. Okay, that is about the transition function. Okay, the last one how you'll write this one. So I'll write for the last one. For the last one, the input state is q1 and the input you have got as epsilon. Top of the stack is z0. You will reach a state which is 2 and will not do anything. You have to remain z0 only. So z0. This you'll write it as accepting state. Accepting state. Okay, this is how you solve the PDA questions. Let's discuss two more questions. The string we take, the number of A's in that string should be equal to the number of B's. How many A's are there? That many B's should be there. So least string will be AB here. It can be 0 also, right? That is also possible. But to make a diagram, we need to have a minimum string, which is AB, so that we can handle it for the cases A and B. And BA, AA, BB, all these are there. With wherever the number of A's and B's are equal, that will be a valid string. So let's take a string, for example, BB, A, B, AA, BA. Okay, how many B's are there? 1, 2, 3, 4. How many A's are there? 4. Okay, we'll finally handle the PDA for this string. Okay, now let's take the stack here. Okay, so initially stack will be having Z0 only. Okay, now the rule is very simple here. So we'll be having a q naught here. Okay, so in the q naught, if my input can be either A or B, starting can be either A, or to handle it for both A and B, and this input is Z naught. So whenever I have starting as A and the top of the stack is Z naught, I'll just push A here. Okay, if A comes, I'll push A. If B comes, I'll push B. Okay, done. Now A and B are pushed here. Now after I have pushed A or B here, if I pushed A or I have pushed B here, let's take another example for the B here. If I pushed A or B, after that I can have A or B at this point, right? I can have A followed by A, or I can have A followed by B. I can have B followed by B or B followed by A. Let's handle A and B first. Okay, if I have another A here, I'll just push it. Okay, whenever A comes, I have to keep on pushing it. A is the input, A is the top of the stack, it will be A here. Same goes for the B also. B is the input, B is the top of the stack, it will be BB. Now this is where A and B came. Okay, So the number should be same, right? The number of A's and B should be same. So if a B comes, I have to pop them both, right? Because these both cancel each other. Like that only if A comes, I have to cancel each other. So a B after A and A after B, in both the cases there should be pop operation and it will remain in the same state. Okay. So here we'll be having B as the input and the top of the stack is A, will be popping it, and if A is here and the top of the stack is B, will be popping it. So once we do all this and the input is over, we'll reach a state where the input is null and the top of the stack is z naught. Okay. So here we'll reach a state where epsilon is there and z naught is there. In that case, I'll keep it as z naught only, and I'll reach the final state. Okay. So let's handle it for this case. Okay. So in this case, what is the thing we need to consider? Z naught is here. B came after Z naught. If B comes, B Z naught, what it should write? B Z naught, it should push it. It will remain in Q1, Q naught only. Then another B came. If another B comes after B, I have to write BB. We'll just keep on adding here. After that, A came. When A comes after the B, we have to pop it. Okay, so this is popped. Let's erase this one. Now B after B, I have to push it, remain in the same state, and A came. If A came, I have to means pop it. Then another A came, I have to pop this one as well. Okay, and B came after B Z naught. I'll put here as B and A, and I'll pop it. Okay, so here Z naught is present. The input is null. If null and Z naught, then I'll reach the Q1, which is a final state. Okay. This was about the PDA where number of A's and B's are equal. You have to write the transition function also. Okay, transition function also you have to write corresponding to this one. Okay, in the same way how we solve for the first question. Moving on to another question, which is the PDF. Here we'll have given as a power n and b power 1. This is a slightly different question. Pay attention. So here the least string is n is greater than or equal to 1. So it will be a b b, it will be a b b b b, and so on. Okay. So here the main thing which you need to do is for each a I have to put two b's. Okay. A I have to put two b's. So if I encounter two b's, a will be popped like that. Okay. Previously a and b was there. B encounter a pop, but here it will be if two b's come, then only a will be popped, and initially all a's will be there, then only b's will be there. That's the condition here. A n followed by b power 2n. So for two b's when I encounter, I have to pop a. How will I ensure if I have reached two b's or not? Okay, so let's get started. So see here, the first state will make here as q naught. Okay, that's the first step you will be doing. Now your starting letter can be a or b. Obviously it can be a only because n is greater than or equal to 1. At least one a should be there to handle it for a. Here I'll make the stack z naught. Input is a, top of the stack is z naught. I have to push it. I'll put a z naught. Okay, like that I can take n number of a's here. I can accept, and for each a n I have to have two b n. Right, whenever b comes after a, okay, b is there at the top of the stack is a. Should I pop it? No, I am popping it only when I encounter two b's consecutively. Right, first b I'll not do anything. I'll keep it as same only, and I will move further. Okay, the top of the stack is a. I'll not push or pop anything. A will be there at the same way how it is. Okay, we'll solve it for this question. Okay, a b b b b b. We'll solve it for this one. Okay, don't worry. Now b and a, another a came. Now after b another b comes, then only I have to pop it. Okay, so after one b another b comes and the top of the stack is a, then I will pop a. Okay, top of the stack is a, I'll pop it. Okay, this is the q2 state. Now after that another 2b comes, then only I will pop. So first b will be ensured by this one, b a, it will remain a only. After this another b comes, I'll pop it. So this ensures that two b's are consecutive which are going to pop it. And as you know, we don't handle the dead states here. So one b, another b comes, pop it, another b comes, take it, and another b comes, pop it, like that alternatively. Okay, so that will ensure that the two times b comes, one a is getting popped. Okay, and finally when the input is over, we'll have epsilon here, and if epsilon is present here and top of the stack is z naught, we'll keep it as z naught only, and we'll reach the final state is q3. Okay, this is the diagram for it. Okay, let's solve it for this one. A a b b b b b b b. Written it as wrong. one extra we have put. Okay, so it is 4 b's and 2 a's. Okay, so first a is here, stay in the same state, and z not. And after that, if another a comes, I see I didn't handle this one. A, it should be a. If a comes after a, right, it should be a, right. After that, if b comes, b a a. If b comes, don't do anything, stay here only. Another b comes, b a epsilon. So this will be popped. Epsilon means pop the top of the stack. This one will be popped, and I'll reach this state here. Now from here, another b comes. Now we are talking about this b. Okay, this b has popped. I mean, this and this b has popped this one, right. First b came here, second b came here, first and second b popped this one. Now we are in the third b we are going here, not doing anything a. Now we are in the fourth b. Okay, in the fourth b, what will happen? In this state, the b will come here, b a epsilon. B and top of the stack is a epsilon, so pop it. This b and b popped this one. Okay, so now it is the case that the z naught is here and the end of the string, which is epsilon here. So epsilon and z naught, it will reach this state. Okay, this was a transition diagram. You have to make the transition function as well. Okay, that's all for this video. And if you found this video helpful, please do like and subscribe. That helps me make more videos like this. Thank you so much for watching. I'll see you in the next one.